Alright, here's the congruent triangles and transformations frame. So if you don't have one, you can get an empty one by printing it off from the website. I'll put the information on the in the description of where the website is so you can grab those. Okay, so what you're going to want to do is probably just pause and copy certain things. I'm going to kind of go through it really quick because a lot of it is we've done in class and it's just more copying down the notes. Okay, so dealing with congruent triangles first. So we use certain rules to determine if triangles are congruent. Okay, and instead of having to prove that all the angles and all the sides are congruent, we have some shortcuts. Okay, and there's four main rules that we can use to do that. Okay, so the first is the side rule. Okay, basically, if I have two triangles and all three corresponding sides, now corresponding means same position, if all three corresponding sides are congruent, then I know the two triangles are congruent. Okay, the next is a side angle side. So if I get rid of one of those sides, okay, so now I've only got two sides, and the angle in between I know that's congruent, then I know that these two triangles are congruent. And once I know what the triangle is congruent, then I know that everything else is congruent. Okay? So now if we drop off and only have one side, how does it work? Well, there's two rules with one side and two angles. First is angle, side, angle. So if I have two angles, like here, and the corresponding side in between is congruent, the two triangles are congruent. Also, if I have two angles and a side that's not in between, that also works. So basically, two angles and a side, I know the triangle is going to be congruent. Okay? So, what's not a rule? This. Two sides and one angle when the angle is not in between the two sides, when the angle is not made up of the two congruent sides, definitely not going to work. Another one that doesn't work is angle, angle, angle. Okay? Those are similar triangles, not congruent. One other thing to mention, oftentimes when they make your triangles, they'll have them share a side. Whenever it shares a side, that side is congruent, so that one counts. Another thing they may do is have triangles where one of the vertices touch. Okay? If you have angles that form an X, the opposite angles are always going to be congruent. They're called vertical angles. So those two angles would be congruent, and then depending on what else we had going on, we could look at that. So make sure if you didn't get all these notes that you pause this, copy this down, and have it ready to use. Okay? Okay, now the other part is those transformations, those rigid motions. Okay? Rigid transformations. So the first is a translation, also known as a slide, when we just move the shape on the graph. Okay? So the idea, you can write the rule this way, where you take their points, the x and the y coordinate, and then you add the horizontal movement and add or subtract the vertical movement. Okay? Negative goes left, positive goes right. For the horizontal, positive goes up, negative goes down on the vertical. Okay? Now the shape we start with is called the pre-image, and where it moves, we call that just the image. And generally we use apostrophe marks to do that, and we call it prime. So this would be triangle ABC for the pre-image. The image would be triangle A prime, B prime, C prime, and that's how we say it. Okay? And that's dealing with the translations. Next we have is reflections. Okay? A reflection, also known as a flip, we need a line to reflect it over. Now, we could reflect it over the x-axis or y-axis. If that's the case, we have this rule to look at to help us understand. Okay? So if we reflect over the y-axis, so in the case would be like this blue one to the red one, okay, over the y-axis, you take the x values and just switch them. If they're negative, they become positive. If they're positive, they become negative. The y values stay the same. Now for a reflection over the x, that would be like this to green, blue to green, or purple to green. Okay? Now the x and y values, the y changes from positive to negative or negative to positive, and the x stays the same. Now if you're just given a line, like a horizontal line, like y equals 5, okay, generally it's easy to just see the distance to that line and then mimic it. So as I was saying, just that distance and remake the shape. Same if it's a vertical line like x equals -6, okay, then you can just reflect it over that as well. Now the last ones are rotations, also known as spins, okay. The way to think about it is, like in a quadrant here, if we make a full circle, that's 360. So if I go only one quadrant, that's like 90 degrees. 2 quadrants would be 180, and 3 would be 270. Okay? So sometimes they need a point to rotate around. Generally, we like to use the origin. Okay? Now, we've got a few rules to help us with this because it can be tough to visualize here. Okay? And so we're starting right here, and we're doing a 90 degrees rotation counterclockwise, which is the same rule for a 270 degree clockwise. So you take the x and the y, you swap them, and the y becomes the opposite. If it was negative, it becomes positive. If it was positive, it becomes negative. Okay, and we get that red shape. If we're doing a 180, we just take the x and the y's, they stay in the same spot, but they become the opposite. So either both negative or both positive. Doesn't matter if it's counterclockwise or clockwise, it's the same thing. Okay? So then the blue, if we go a 270 degree counterclockwise or 90 degree clockwise, okay, same thing, we take the x and the y, we swap them out, x becomes negative and y stays the same. Okay, and that's basically it, guys. So make sure you write these down and have them ready to go.